Hey guys, welcome back. In this video, the question which we're gonna discuss is to find the DFT of 1000100. Okay, so the moment you see this question, what comes to your mind is to apply 8-point DFT, right? So this is a potential interview question. Okay, so you guys, I will let you guys to mention where this question has been asked. Okay, so usually this kind of questions will be asked in interviews or in examinations, in the competitive examinations like GATE or ISRO, things like that. So if you try to apply 8-point DFT, it will take a lot of time, but definitely there should be a trick, right? When this question is asked. But let's say in interview this question is asked, and if you don't answer, the next question is what is the DFT of 10101010. Okay, so let us try to solve this question. So the question is one. So this is our this one, right? If you clearly see, you know, this is repeating, right? So I would recommend you to actually have the DFT matrix in your fingertips, especially for 2-point and 4-point. Okay, so 4-point, let us say it is there in your fingertips, so it will be 1 1. Okay, so even before you gonna solve it, see 1000, right? So um, if you multiply, actually the last three terms are going to be zero, so it doesn't matter what terms we have here. So the output will be 1111, right? Okay, so if you take just the DFT of this one, it will be all ones. But now the thing is, we need to apply one property, very important property, that is the replication in one domain is interpolation in the other domain. So this is a very important DFT property. So here replication, okay, replication is happening 2 times, right? So the interpolation will be a factor of 2. So the interpolation factor p is equal to 2, which means what? Like between the samples, we need to insert p minus 1 zeros, right? So based on this DFT property, so in the replication is happening in the time domain, right? So 2 times replication is happening. So in the frequency domain, it will be an interpolation p minus 0. We need to interpolate. So this is our frequency domain samples, right? To this, I should be applying 10. I mean, I'm just doing the interpolation. So this is how after interpolating with factor p is equal to 2, I would get like this. But there is a scaling factor as well. So we are inserting zeros. So interpolation will happen with factor 2, but and also there is a multiplication by p. So what I will say is I will get to the exact what I would say, I will get to the exact formulas of this one. So in this case, the multiplication factor is p. Okay, so here to this I need to multiply by p, which is like 2 into this one. So I hope you got the answer, right? Hmm? So but can we solve it in different way? Let's say you don't know 4-point DFT, and let's say they have asked this question to find the the DFT of this one 101010. So in this case, you can see that this is replicated 4 times, right? Or in another way, let's say I will take the first one itself. So I have taken this much, but we know the replication and interpolation, right? As per the property of DFT now. So I have just taken this 4 points. This is like actually, so there is 10, but this is the interpolated with p is equal to 2, right? P is equal to 2, which means p minus 1 should be p minus 1 zeros should be inserted. So now what is the DFT? 2-point DFT we know, right? Very easily we can write it. That should be there in the fingertip. This is the one. So finally I will get 1 1. This is the output. Now in the time domain there is an interpolation. Okay, so rather than just 10, now we have 1010. There is an interpolation. So time domain interpolation in the frequency domain, it should be a replication, right? So here interpolation factor p is equal to 2. Here replication should happen p fold. So what will be my output then? My output is 1 1. This is okay output, and the p fold means 2 times. So again 1 1. So this is my output, right? So this is exactly what we saw. So if I take directly 4-point DFT also, I would get all ones. That's what we saw in the previous slide, right? All ones. Now the same property holds good. Okay, the second, the replication in time domain. Now we have to do interpolation in the frequency domain. So I hope this concept is clear. You can now work out on how to get the DFT of this one. Okay, this would be pretty much simple. Now I will just try to mention where these formulas are present. So I have already uploaded my short notes related to DSP, right? Wherever I have mentioned this high, okay, wherever I mentioned this high, all are important for interview. So in the previous video also I was talking about DFT equations. So DFT equations are captured over here. Okay, these are all very much important. Especially I was talking about to use use DFT to find IDFT. So that answer is straight away available in this point 16. So this video also I will put it in the cards. Okay, so you can go ahead and watch. I will also try to put it in the description. And where is the formula which we have used? Yeah, it's here. So the replication in one domain corresponds to zero interpolation in the other domain. So what we have used is 100 1000, right? So twofold replication in time domain. So my output should be interpolated and multiplied by factor of p, right? So the other property is that signal is zero interpolated. Okay, so we saw that as well in this case. So if it is zero interpolated by p factor, then the output should be p fold. This also we saw. Okay, verified. I hope you got where to look at the formulas and how to solve this. Thank you very much. Have a great day. Bye bye. Please do subscribe if you appreciate the efforts.